All right, and here is the doozy of them all. What it tells you to do is that you're taking water vapor, which is a gas, from 106 degrees Celsius, and you are going all the way down to -3 degrees. So what you want to ask yourself, do you ever go between the numbers 0 or 100? Do you ever hit those points going from 106 to -3? And the answer to that is yes, you go through all of them. So when you're trying to do, this would be a cooling curve because you're going from 106 down to -3. You need to deal with 106. First, it's going to hit that 100 mark. And at the 100 mark, what it's going to do is it's undergoing a phase change and it's condensing down. Then, after it's all condensed, you are going to decrease your temperature once again until from 100 down until 0 degrees. And at 0 degrees, once again, it is going to level off, and this time it is going to freeze. And then finally, once everything's frozen, it's going to undergo a temperature change once again to -3. So if I were to label this, this would be my -3. I would know that this would be 0. I would know that this top number right here would be 100. And I would know this would be 106. Okay, I know it levels off at all the phase changes because it is water, and those phase changes occur at 100 and 0. Okay, so the first problem that I'm going to do is I'm going to be dealing with this 106 down to 100. So 106 down to 100. As I've done in the previous problems, I know that anytime I am going down, I am going to be using, as far as temperature goes, I'm going to be using Q equals MCAT. So I know my Q. I need to use my mass. My mass in this case is going to be 20 grams. It's always going to be 20 grams. My C for this situation, looking at the very front of your page, is going to be the C for gaseous water. Okay, so that would be the 2.00. And then my delta T is 100 minus 106. So in this case, you're going to get a negative number. That would be -6. Solving for this, you end up getting -240 joules. Okay, so that's the first one. Now I want to deal with that phase change of condensing. So I'm going to write down condensing. Okay, and anytime you are undergoing a phase change, you are going to use Q equals HM. In this case, you are undergoing the condensation, which is a gas to a liquid, and your H value is -2,260 for that. Okay, why is it negative? Because it's the exact opposite of vaporization. So all you do is you make it a negative sign. So I'm going to do Q equals -2,260 times my mass, which once again is always going to be 20 for this problem, multiply it out, and I end up getting -45,200 joules. All right. Now I'm ready to do the cooling down of liquid water, which is 100 to 0 degrees. So I'm going to write down 100 to 0 degrees. And once again, knowing that it's decreasing in temperature, I know I'm going to be using that MCAT formula. So I'm going to do Q equals, my mass once again is 20. My C value for all liquid water is 4.18. And my delta T in this case is 0 because it's final minus initial. So once again, you get a negative number, which is -100. You should always be getting the same sign. So if you're always getting positives, then you should get positives for the whole problem. If you're getting negatives, you should be getting negatives for the whole problem. So when you multiply this out, you end up getting -8,360 joules. So now I've dealt with cooling down my steam, condensing my gaseous steam into liquid water, and then cooling down my water to 0 degrees Celsius. So now I'm ready to freeze it, which is that flat line. Okay, and once again, anytime you are freezing or undergoing a phase change, you're going to use Q equals HM. So looking at this, my H value would be the fusion one, but I'm doing the exact opposite because I'm going from a solid or a liquid to a solid in this case, as opposed to a solid to a liquid. So my H value will be the negative value of that. So Q equals negative. My H value for that is 334 for water. times my mass once again, which is 20. And so when I multiply this one out, I get negative 6,680 joules. And now I'm ready to deal with the cooling of my solid ice water. And so it's going to be from 0 to negative 3. Okay. And so I'm going to be changing my temperature once again, so it'll be MCAT. So we've got Q equals, once again my mass is 20. My C value for solid water, if I look on my front, is going to be that 2.00. And then my delta T is negative 3 minus 0, so that would be a negative 3. And so when I multiply this out, I get negative 120 joules. But once again, the whole energy that was released during this process is going to be all of them added up. So I'm going to have negative 240, oops, should be negative 240. And I'm going to add my one from condensing. So that would be negative 45,200. And then I'm going to add the energy done by the cooling of the liquid water, so 8,360. And then I need to add the energy that was lost while freezing, so 6,680. And then once again, I'm going to add that of the 0 to negative 3, so the cooling of your solid, so that would be negative 120. And so when we add all of that up, we end up getting negative 60,480 joules. So when you look for your sig figs, there are 2 sig figs from the 20. There's one from the negative 3. So I guess this answer should not be negative 61. It should be off of the 1 sig fig from the negative 3. So we're going to round to negative 60,000 joules, which once again, if you just want to move it over 3 to make it kilojoules, that would be negative 60 kilojoules.